Hi, and welcome back to the Save It for Parts channel, where today we've got something really exciting. I am going to be building my own satellite. Now, this is a CubeSat kit from MySat in Ukraine, and I actually bought this. This is not a sponsored review. This isn't a sponsored product. I paid my own money for this, and this is actually the first affordable CubeSat kit that I've come across. There are other kits that promise to let you build your own satellite, but they are $500, $1,000, even for just an educational CubeSat simulator, not something that's intended to go into space. And this is much the same. This is not actually rated to go into space, but it has a lot of the same parts that would fly in space, and it uses a lot of the same technology that was developed for CubeSats, like 3D printing, single board computing, all kinds of little add-on modules and sensors. And this one is much closer to $100 US. I think right now they're about $130. This was a Kickstarter a while back, and it's now a product that you can actually go online and purchase from Ukraine. And I think that's pretty cool in itself, that a small independent company can operate out of a country that Russia is trying to just bomb out of existence on a daily basis. They are still able to produce a homegrown product, make it more attractive, more affordable than competing products out there, ship it to the US, all the while basically dodging Russian attacks. So if you want to support Ukraine and buy something like this from them, I will put links to them down in the description. Again, not a sponsorship at all. I just thought this was a really cool product, and I'm really looking forward to trying this out. So CubeSats were something developed back in the 90s for education and research. They are an attempt to make a minimal size, minimal cost satellite, something basically a small 4-inch cube that can be launched along with other satellites on a less expensive basis. Sometimes they get a free ride share on commercial missions. Sometimes they get free ride share along with NASA or other science organizations. And these can be built by students, they can be built by universities, by high schools, and they can do things like ham radio, simple science experiments, they can have cameras, they can transmit slow scan television. There are a bunch of CubeSats up there in low Earth orbit, and these have gone as far as Mars. These have actually been used for actual scientific missions. And there are various sizes of CubeSats that kind of are multiples of this base dimension. Again, this particular one is more of a simulator, and I will not be sending this into space. It's not rated for that, and I can't afford the launch costs. It is still pretty expensive to launch stuff into orbit. So we will be building this on the bench here and playing around with it, seeing what it does, and maybe doing a little bit of improvement over the base kit. We'll just have to see what happens. So let's get this thing open and see what we've got. And this notes this is a beta version of the MySat satellite kit. It's intended to be a 2-in-1 educational kit and a model of a real satellite, and you can control it the same way as real satellites through a radio. You can kind of see that it's an expandable system because there are other optional modules that I did not get, but I have the a basic board here. I have a 3D printed, I believe this is a solar panel deployment mechanism. So this has a little servo, and I think this kind of unfolds some wings. One of the tricks that CubeSats use to stay small and fit within a standard deployment mechanism is that they will often fold up into a cube, but once they're launched, they'll deploy things like sensor booms, like antennas, like solar panel wings. Now, one of the optional extras that I did buy is this telemetry radio. We have one of these cool things, the remove before flight tag. So this is basically the power switch. You keep this plugged in to keep your satellite turned off, and once you're ready to launch, you pull this out. I almost forgot there's an antenna, and underneath here, we do have another board. Down one layer in the box here, and we're gonna have to move the box out of the way to show all this stuff off. We have a bunch more parts. So we have some connectors and standoffs. We have some little sensor modules. And I am getting more and more familiar with little modules like this when I play around with Raspberry Pi and Arduinos. We have what looks like an ESP32 module. This is probably the brains of the operation. Although we have another little microcontroller. This looks kind of like an Arduino. Sometimes these kits, or even the actual real-world satellites, will have multiple CPUs. They will have multiple embedded computers on them to handle different aspects of the mission. This looks like a radio module with an antenna. And this looks like maybe a programming interface. It looks like a USB to serial adapter. And then down in the bottom here, we actually have some solar panels. Now I I didn't think I ordered the version with the solar panels, so maybe they threw in an extra here. Okay, so we have all these great parts. The main things that are missing are the frame, which is a 3D printed part, and instructions. And the instructions are going to be online on GitHub, as the letter mentions. Now, I was hoping to start 3D printing some parts, but unfortunately, my 3D printer looks like this at the moment. Fortunately, I don't need the 3D printing until about step 3 of this process, because we can install all of the Hi, yes, thank you. First, we're going to put all the electronics together, and then we have some programming to do, and then finally we can get to the frame. Well, so far we have our main computer, the ESP32 cam, and we do have the camera module on that. This chunky guy is a real-time clock that gives this onboard timing. We have the battery controller over here. In the middle we have the MPU, gyroscope, and accelerometer module. Up here is an analog to digital module, and this is used for solar navigation. We also have an environmental sensor down here. We need a couple more modules installed on board B on the bottom. And that includes the auxiliary computer, the Arduino Nano here, and our HC12 radio module. Now the boards here actually have some additional solder pads for extra payloads, for battery charging, for antennas, for other loads. So you can do other stuff with this. As I said, it's kind of an expandable kit. So if we wanted a bigger antenna than just this little springy guy, I think we could put something on here like a tape measure antenna. That's a pretty common one for ham radio CubeSats. But for now, we're just sticking with the default little springy guy, and I'm going to try to keep the cats from eating that. We're not done yet. We have a bunch of these little wired modules to go in place. We have a number of these photodiodes. We have this big LED called a star, and we have this little signal LED, and it's kind of hard to see where that goes. So that is basically our electronic stack done. We can power this up in several ways. We can use the USB connector here on the board. We can use the programming connector, or we can use the onboard battery. But we need to install some firmware first. We need to install the custom operating system onto the two boards, onto the main computer and the auxiliary computer. So another difference between a launch-ready satellite, a CubeSat that's actually going to orbit, and this little model here, this simulator, is that we would probably have more rigid connections because satellites are subject to a lot of vibration, a lot of different G-forces, both during the actual rocket launch and then during deployment. And, you know, some of these connectors are a little bit loose. Some of these modules that just pop in, I don't know if those would hold up to actually being launched. So in real-world use, you would probably solder these into place, or you'd have some other method of actually connecting these that would not be subject to vibration, that would not come loose under different G loads from different directions. Step 1 went so fast that I'd like to get the 3D printing part going while I work on step 2. So I remembered I actually do have a backup 3D printer, or at least all the parts for one. So thank you to viewer Dennis the Menace for sending me this. Now I just have to remember how to put this together. While the 3D printer is busy making spaghetti, I got the ESP32 files downloaded for Arduino IDE, and this took me a few tries to get right. I had to make sure I had exactly the right ESP32 version, and then I actually had to delete my existing Arduino libraries, re-download the libraries for this project from GitHub, get those extracted into the library file, and then about the third or fourth time I tried to compile this, I got it to actually go through. If you're trying to do this yourself and you run into the same problem, there is a troubleshooting guide within the Google document for the instructions on this. Now, even though the ESP32 module is a little faster and more capable than the Arduino, it doesn't have a USB interface. So we'll have to use ye olde serial interface to get the firmware onto this thing. So if all of that worked, then our satellite brain should have all of its programming. Both brains should have the programming that they need. And now we need to assemble the 3D printed shell. So my memory card filled up during the build montage and we had to finish a couple details off camera, but now I have a satellite, or at least a satellite simulator, because as I mentioned earlier, and as Jeff Geerling found when he did a video on one of these, they are a little too weak to probably actually survive launch and space flight, especially these solar wings. I don't know if Jeff's had these, but these things are pretty flimsy and I think they would pop off. They do come up and down with a servo, but yeah, getting these in place was probably the trickiest part, getting the tiny little connectors in place, making sure none of the wires were pinched. And I think there are still maybe some wires pinched on the side here. There's not a great way to route these. This all went together fairly smoothly. My 3D printer definitely made some pieces a little bit smaller with the tolerances, like the little, these little square nuts. They definitely went in better on the top plate, which is the one that MySat sent me. And again, I'm not sure if this top plate was supposed to come in my kit. I thought I bought the basic kit and not the one with the solar wings, but maybe they just threw that in for me. I don't know. As I noticed while building this, it seems like multiple teams, or at least multiple people, were involved with the 3D prints were probably one person, the electronics were one person, the instructions were another person, and while I'm sure they coordinated, they maybe didn't coordinate all the time because not everything quite worked the way it was supposed to. For example, my front panel here is kind of bulging a little bit because one of the inserts was not correct for the electronics piece that was there. I actually had to take my snippers and modify that 3D print, and then it was also too thick, so it hits the circuit board here and it kind of pushes that panel out a little bit. It's not super noticeable on camera maybe, but I can definitely see it up front. Other than that, really no issues getting this together, and I think it looks pretty good. The only thing that would make this look better is to peel off the protective film on everything. And yes, I had to use tweezers for several steps in this process because my big fat fingers do not fit in here properly. Okay, I think we're finally ready to turn this thing on and see if we can talk to it with a radio. So I'm going to remove the remove before flight pin. And should have gotten my hands out of the way there because the solar panel's folded up, but yeah, I think it is now activated. Now I'll be using the MySat ground station module for this. I did pay a little bit extra for this guy, and I believe what this is just a wireless serial radio and then a USB adapter. And so what this does is basically just take my serial commands from something like the Arduino IDE, send them out over 433 megahertz. So if I plug this thing into my computer, so that shows up as, I think, COM 4 over here. That did not seem to work. So I'm going to check if the radios are actually working using an SDR. So if I go over to the serial monitor here, I'm going to see how many windows can I have open on top of each other at once. We do get a blip on the waterfall centered around, it looks like 433.4, which that's correct. That should be channel 1 in this thing's addressing schemes. All right, I am not getting any transmissions from the CubeSat. So if I want to show more output on the screen, I'm just going to paste in the entire how-to guide from MySat and send that. Turn this all the way down to like 300 baud. Now we can actually spam out a lot of stuff, and this actually looks like a real satellite signal. This looks like satellite signals that I've seen coming down from space. I'm not seeing any transmissions from the satellite, and I'm not sure if it's supposed to send out like a ready signal or any kind of transmission before it's talked to with the ground station. I'm wondering if part of the problem, if it's getting stuck on these solar panel steps. The servo sounds like it's still trying to run when I pull this out, and these panels do not fully fold up. I think they're getting caught. These 3D printed parts are getting caught on these 3D printed parts. There definitely were parts of the STL files that did not fit together no matter how much I adjusted my printer. So I'm pretty sure like the inserts and the walls are from 2 different versions of this. And it's possible that the section up here, which they sent me, and they had 3D printed on probably a better 3D printer than mine, this might be even from a 3rd iteration of the files. So it's possible that just all these parts don't quite fit together and I might have to reprint something. But as you can see, if I pull out the go pin here, yeah, it folds, it tries to fold up, but it doesn't fold up all the way. And you can hear that servo continuing to try to run. It's possible that that is interrupting the boot process. Now I could try to fix that the right way and redesign the STL files, reprint these side panels, reassemble the entire thing, which sounds like kind of a pain. Or I could do it the save it for parts way, take a hot knife and just shave off a little bit of this piece of the side panel. Well, after some careful surgery, this is as close as I can get the solar panels to fold in, and that servo still wants to run, so we might just have to disconnect the servo and leave it alone for now. All right, I plugged this thing in with the USB cable again, and we've gone over to the Arduino IDE, and now we are getting live telemetry, so it's sending telemetry over the serial connection. It's just not working over the serial radio. Let's see if I can tell it to do stuff. If I say turn LED again, okay, it seems like it's not accepting commands in, it's just sending stuff out. So it may seem like this thing has a lot of little issues, and it kind of does, but they're all small issues, and really troubleshooting and fixing problems is part of building a satellite, and that's something you have to learn. If you're trying to build a real satellite, you have to iterate, you have to make prototypes, 3D printed prototypes, and you'll have problems like the 3D printing not fitting, like the code not working, like the communications not working. And you want to practice getting all of that stuff working before you actually launch it. So the bugs with this product kind of make it more realistic, and it's much more realistic to me than just a toy you buy at Walmart that's all ready to go and you just snap some pieces together. This is really more of a learning experience. All right, I re-downloaded the firmware, reflashed the firmware, and it is giving me slightly different telemetry now. So I'm wondering if I had an older version of the firmware before. I thought I had grabbed the link for GitHub off of their official website, but I'm thinking there's several GitHub repositories and maybe I grabbed the wrong one. So we can talk to our satellite, we can command our satellite with USB, but that's not very space age. Let's see if we can do it with the radio. We are now transmitting from the satellite. We can see that here. We can see these little blips on 433.4 megahertz. Those are coming from the satellite. And if I send something from my computer, like turn LED, and it works. We've got that bright star LED turned on. I did finally get the web server to work, and I think what helped was to put an SD card in the ESP32 module. It did not come with an SD card, and I never saw an SD card mentioned in the manual, but there is actually a slot in there. And we are able to get on the web server now, and we are able to get it to take pictures and update pictures on the web server. Now, it would be really cool if this thing could send photos over the serial radio, but I think we might need a different firmware for that or some kind of update because I don't think it's really designed for that right now. We can charge with USB, and we even get a little charge indicator on the battery control module. Or we can put it in the window and charge with solar when we aren't being eclipsed by the cat here. Well, I'm pretty happy with the MySat CubeSat simulator here. This thing is fantastic. It was a lot of fun to put this together. It was fun to even work through some of the problems that I have, do some of the troubleshooting, figure out by trial and error what I can improve, what I can make work. That is how I work best, just trying things. And if they don't work, changing something a little bit and trying it again. And a low-cost satellite simulator like this is exactly what I need to be able to do that without worrying about breaking something expensive, without worrying about screwing something up too much. This is a fantastic learning platform. It's a fantastic experimentation platform, and I'm actually already thinking of things I could add to this with some of the expansion options on it. And if you don't want to go through the hassle of 3D printing and trying to make your flaky 3D prints fit this thing, I think you can also buy the entire kit with the panels already pre-made. So that probably would have saved me a lot of headache trying to get things to fit, trying to get the solar panels to work up and down. I could put it in a vacuum chamber. I do actually have a vacuum chamber thanks to Axeman's Surplus, as well as some vacuum pumps. So that's something we could try. We could try chilling it down to the low temperatures or heating it up to the high temperatures you'd encounter in space. Again, the 3D printed frame maybe isn't suited for like super direct sunlight in space, especially some of the darker colors I used here. This was just what I had for filament. So you might also want to glue or secure some of the electronics in place for vibration resistance. I think you could potentially make this a launchable, ready-to-fly satellite with a few modifications like that. Now, will I be doing that? No, because I cannot afford the $50,000 to $100,000 it costs to actually launch something this size into space. Now, another thing we could try to do with this in the future is use it on a weather balloon, use it as kind of a satellite simulator in a A lot of people like to call high-altitude weather balloons as a near-space environment. I think that's a little misleading. There was a whole thing a few years back where everybody would put their garlic bread on a weather balloon and say, "We sent it to space!" No, you just sent it really high in the air. So I don't like calling high-altitude balloons close to space, but they are kind of the closest you can get on a budget, and it is a way to test CubeSat hardware by putting it on a balloon and sending it up as high as you can go to see if it will work at low pressures, low temperatures, things of that nature. I actually have all the parts for a weather balloon. I have the balloon, I have parachutes, I have a radio sonde. I just don't have helium. That's the expensive part. So we're gonna have to think about that one. That might have to be another video in the future too. Anyway, I think we're going to wrap this video up. I would like to thank all of my Patreon subscribers for helping me afford projects like this, helping me buy stuff online like cool CubeSat simulators. If you want to become a Patreon member and help support the channel, I will put links to that down in the description. I'd also like to thank Jeff Geerling for cluing me into the existence of the MySat kit. I had heard of other CubeSat simulators, but I was not aware of this one until he mentioned it on his channel. So thank you, Jeff. This thing's really cool, and I'm glad you let me know about it. I'll put the link down in the description as well as up here to the MySat Kit website where you can order all the different versions of their CubeSat. And I will also link to their GitHub page, the most recent one with their updated firmware that I used on this. Again, this is not only a great way to get an affordable CubeSat simulator kit for yourself, for a friend or family member over the holidays, for your students at a local school, but it's also a great way to support a small business over in Ukraine and help keep their economy going during a very challenging time for them. I hope everyone has enjoyed this video. If you want to see more satellite content, I do a lot of satellite communication stuff. If you're new to the channel, go back and check out some of my other videos in the satellite and radio playlist. And you can always like and subscribe so you don't miss any future satellite projects we come up with. Finally, thank you to everyone for watching, and we'll see you next time.